voltage drop in a circuit can be caused by several factors, so a systematic approach to troubleshooting is essential. Firstly, consider loose or corroded connections. You'll want to check all wire connections in the room, including those at the panel, outlets, light fixtures, and appliances. A loose connection increases resistance, which leads to a voltage drop under load. Secondly, consider damaged wires. Inspect the wires for any cuts, nicks, or insulation damage that could be leaking voltage. Even small imperfections can create a path for current leakage, leading to voltage drops. An overloaded circuit is another potential cause. The number of electronic devices in the room may be drawing too much power from the circuit, causing a voltage drop. This is especially common with multiple computers, printers, and other office equipment running simultaneously. Improper grounding can also result in voltage fluctuations. A poor ground connection can prevent proper dissipation of fault currents, leading to voltage instability. Check the ground wire and the grounding system to ensure they are properly connected and functioning. Malfunctioning appliances can also cause voltage drops. The copy machine or another appliance may have an internal issue that is causing power fluctuations. These fluctuations can affect the voltage stability of the entire circuit. Finally, the circuit may require a superneutral. If the circuit has multiple appliances and devices drawing high currents, it may require a superneutral to handle the increased load and prevent voltage drop. A superneutral provides additional capacity for carrying neutral current, reducing voltage imbalances. To troubleshoot the problem systematically, firstly, inspect the connections. Tighten any loose connections and replace any damaged ones. This ensures that the circuit has solid, low-resistance connections. Secondly, test for damaged wires. Use a voltage tester to check for voltage drop along the wires, which could indicate a damaged wire. This helps identify any points where voltage is leaking or being lost. Monitor the power usage. Check the amperage draw of the appliances and devices in the room to ensure they are not overloading the circuit. This can be done with an amp meter or clamp meter. Next, test the appliances. Disconnect the appliances one by one to identify any malfunctioning units. This helps isolate whether a specific appliance is causing the voltage drop. Check the grounding by measuring the voltage between the ground wire and the neutral wire to ensure proper grounding. A high voltage reading can indicate a grounding problem. Consider superneutral. If other troubleshooting steps do not resolve the issue, consider installing a superneutral to provide additional neutral capacity. This is especially important if the circuit is heavily loaded with electronic equipment. There are also additional considerations to keep in mind. Some appliances, such as motors or compressors, can cause temporary voltage drops when they start or stop. These fluctuations are normal but can be exacerbated by other underlying issues. The age of the wiring may also contribute to the problem. Older wiring may be more prone to loose connections and insulation damage. This is because over time, wires can degrade, leading to increased resistance and voltage drops. Environmental factors such as moisture, heat, and pests can also contribute to electrical problems. Moisture can corrode connections, heat can degrade insulation, and pests can damage wires. Considering a neutral to ground voltage of 2.4 volts is present, this could also indicate a problem. Ideally, the neutral to ground voltage should be as close to 0 volts as possible. A reading of 2.4 volts suggests that there is current flowing on the ground wire, which can be caused by several factors including unbalanced loads, loose neutral connections, or ground faults. A high neutral to ground voltage can also cause sensitive electronic equipment to malfunction or experience performance issues. It's crucial to identify and address the underlying cause of this voltage to ensure the safety and reliability of the electrical system. To mitigate these issues, you should consider the following actions. Check the main neutral connection at the service panel. Ensure that the neutral conductor is properly connected and tightened. A loose neutral connection can cause voltage imbalances and increase neutral to ground voltage. Verify that the loads in the circuit are balanced. Uneven loading can cause current to flow on the neutral conductor, increasing the neutral to ground voltage. Redistribute the loads as necessary to balance the current flow. Inspect the grounding system. Check all ground connections to ensure they are secure and corrosion-free. A faulty ground connection can compromise the effectiveness of the grounding system and increase the risk of electrical shock. Test for ground faults. Use a ground fault locator to identify any ground faults in the wiring or equipment. Ground faults can cause current to flow on the ground wire, increasing the neutral to ground voltage. If the initial troubleshooting steps do not resolve the issue, you may need to consult with a qualified electrician to perform a more thorough investigation. They can use specialized equipment to identify and address the root cause of the voltage drop and neutral to ground voltage. Here are some more expanded details on the points already discussed. Firstly, expanding on loose or corroded connections. Loose or corroded connections are a common cause of voltage drops in electrical circuits. Over time, connections can loosen due to vibration, thermal expansion, or physical stress. Corrosion can also occur due to moisture, humidity, or exposure to corrosive substances. These issues increase the resistance at the connection point, causing a voltage drop when current flows through the circuit. To properly address loose or corroded connections, firstly, visually inspect all connections in the circuit, including those at the panel outlets, light fixtures, and appliances. Look for signs of corrosion, discoloration, or physical damage. Secondly, use a screwdriver or wrench to tighten any loose connections. Ensure that the connections are snug but not over-tightened, as this can damage the wires or terminals. Thirdly, clean any corroded connections using a wire brush or chemical cleaner. Remove all traces of corrosion to ensure a good electrical connection. Fourthly, apply a corrosion inhibitor to the connections to help prevent future corrosion. Fifthly, replace any damaged or corroded connectors or terminals. This ensures that the connections are in good condition and will not cause future problems. Expanding on damaged wires. Damaged wires can also cause voltage drops in electrical circuits. Wires can be damaged by physical stress, heat, moisture, or pests. This damage can compromise the insulation, reduce the cross-sectional area of the conductor, or create a path for current leakage. To address damaged wires, firstly, visually inspect all wires in the circuit, looking for signs of damage such as cuts, nicks, or insulation damage. Secondly, use a voltage tester or multimeter to check for voltage drop along the wires. A significant voltage drop indicates that there is damage to the wire. Thirdly, repair or replace any damaged wires. If the damage is minor, you may be able to repair the wire using electrical tape or heat shrink tubing. However, if the damage is severe, it is best to replace the entire wire. Fourthly, protect the wires from future damage by using conduit, cable trays, or other protective measures. This helps prevent physical stress, heat, moisture, or pests from damaging the wires. Expanding on overloaded circuits. An overloaded circuit occurs when the total current drawn by the appliances and devices connected to the circuit exceeds the circuit's capacity. This can cause a voltage drop, overheating, and potentially a fire hazard. To address overloaded circuits, firstly determine the circuit's capacity by checking the amperage rating of the circuit breaker or fuse. Secondly, calculate the total current drawn by all of the appliances and devices connected to the circuit. Thirdly, compare the total current draw to the circuit's capacity. If the total current draw exceeds the circuit's capacity, the circuit is overloaded. Fourthly, reduce the load in the circuit by disconnecting some of the appliances and devices. You may need to move some of the appliances and devices to another circuit. Fifthly, consider installing a new circuit with a higher capacity to accommodate the additional load. Sixthly, use energy-efficient appliances and devices to reduce the overall current draw. Expanding on improper grounding. Improper grounding can result in voltage fluctuations and potentially dangerous electrical conditions. A proper grounding system provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. To address improper grounding, firstly, check the ground wire and the grounding system to ensure they are properly connected. Secondly, measure the voltage between the ground wire and the neutral wire. A high voltage reading indicates that there is a grounding problem. Thirdly, inspect all ground connections to ensure they are secure and corrosion-free. Fourthly, test the grounding electrode system to ensure it is properly grounded. This can be done using a ground resistance tester. Fifthly, install a new grounding electrode system if necessary. Expanding on malfunctioning appliances. Malfunctioning appliances can cause voltage fluctuations and other electrical problems. An appliance with an internal fault can draw excessive current or create voltage imbalances, affecting the stability of the entire circuit. To address malfunctioning appliances, firstly, disconnect the appliances one by one to identify any malfunctioning units. Secondly, use a multimeter to check the voltage and current drawn by each appliance. Thirdly, inspect the appliances for any signs of damage, such as burnt wires or damaged components. Fourthly, repair or replace any malfunctioning appliances. Fifthly, have a qualified technician inspect the appliances to ensure they are safe to use. Expanding on superneutral requirement. A superneutral is a larger than normal neutral conductor that is used in circuits with multiple appliances and devices drawing high currents. The increased neutral capacity helps to reduce voltage drop and prevent voltage imbalances. To determine if a superneutral is required, firstly, calculate the neutral current in the circuit. The neutral current is the difference between the currents in the hot conductors. Secondly, compare the neutral current to the ampacity of the neutral conductor. If the neutral current exceeds the ampacity of the neutral conductor, a superneutral is required. Thirdly, install a superneutral with a larger ampacity than the calculated neutral current. Fourthly, ensure that the superneutral is properly connected to the neutral bus in the panel and to all of the appliances and devices in the circuit. In review, the issues found point to the following possible issues. There could be loose connections, which would increase resistance and drop voltage. There could be damaged wiring, where the insulation is cracked or cut in some way, creating voltage leakage. There could be an overloaded circuit, where the loads on the circuit are too high. There could be grounding problems, where the grounding system is compromised, leading to voltage fluctuations. There could be malfunctioning appliances that are internally causing voltage fluctuations. There may be need for a superneutral conductor, as high neutral current on the existing neutral conductor could lead to voltage drop. When troubleshooting, the connections should all be inspected and tightened if necessary. Damaged wires should be tested and replaced if necessary. Amperage should be monitored to verify the circuit is not overloaded. The grounding should be verified for proper voltage from ground to neutral. The appliances should be disconnected one by one to see if one appliance is causing the problem. Lastly, a superneutral could be installed if the prior steps don't resolve the voltage drop issue. There are other considerations that might be worth considering as well. Certain appliances may cause temporary voltage drops when they turn on or off. Also, older wiring is more prone to failure, so that may be an issue. And things in the environment like heat, pests, and moisture may be impacting the electrical system.